Today we will discuss design of jigs and fixture. So first we need to know what is the importance of a jigs and fixture and where we use the jigs and fixtures in the industries. So basically if we need to manufacture products in a batch, in that case we need to use the jigs and fixture. So basically jigs and fixtures are used when we have to perform a batch production. We know that there are three types of productions are there. One is job production, second is batch production, and third one is mass production. So we will use jigs and fixture when we will when we have to perform the batch production. Now what is this fixture? What is this fixture? Basically fixture is a mechanical device. So it is a mechanical device. It is a mechanical device which is by which we can easily, quickly and accurately hold, or rather we can accurately locate, support and clamp the job that will be called as a fixture. So when we will design any fixture, we have to keep in our mind that the fixture must be, means it should be easily, quickly and accurately, it must have to be locate, support and clamp the job. Okay, so these three conditions we need to fulfill when we have to design any fixture. And this mechanical device must be strong and rigid. So it must be strong and rigid so that it can give support to the workpiece. So basically when we will design in fixture, we will have we have to perform three things. The first one is locating. So at first we need to locate the job, then we need to support the job, we need to provide support to the job, and then we have to clamp the job. Okay, that means we will be needed a locating device or locating system in that fixture, we will be needed a supporting system, and we will be needed a clamp system. Now basically the fixtures, jigs and fixtures are used for the higher productivity, and product quality. Higher productivity and product quality. And the fixtures and jigs are generally used in batch production. Now let's see where this jigs and fixture will be used. Suppose if we have to produce, if we have to produce, suppose there is a disk, there is a disk, suppose this one is a disk, and in the disk we have to make a hole. In the disk we have to make a hole at this position. Okay, so this is the center point of the disk, and suppose at this point we have to make a hole like this. Okay, now to make a hole like this, but this is the top view. Now if we make a front view of this one, then it will be look like this. Then the disk will look like this. This one will be the center point of the disk, and this is the center point of the hole, and this is the hole. Okay, now the hole is at a distance of, suppose from the center point the hole is at a distance of say A. Okay, and the total dimension of the disk is, suppose the total dimension of the disk is, suppose capital D. Diameter is capital D, and diameter for the hole is say small d. Okay, so now we have to make the hole. This is the sectional view of the plate, so the hole can be seen at that time. So now if we need to produce this product, then we have to follow few steps. The first step is, step number 1 will be, we have to mark the location of the hole. Okay, so first point that we have to perform is the marking operation. Okay, so at first we need to perform the marking operation. Now after marking, next we will get the center point of the hole. After getting the center point of the hole, then we have to use center punch. We have to use center punch at the center point of the hole. Okay, so we have to perform the punching operation. So at first we will perform the marking operation, then we will perform the punching operation. Okay, next, in the third step, now we have to mount the job. We have to mount the job, and we have to fix this job in a machine bed. Okay, so we have to mount the job and fix the job on a machine bed. Okay, or we can hold it in a vise. Now after holding it into the vise, now we also have to provide sufficient support in the workpiece. Okay, and we have to use the clamps to hold the job. Now after providing all these things, next we have to align, because as it is a hole, so we can make this hole with the help of a drill. So the center of the drill it should be aligned with the center or with the axis of the hole, right? So suppose this one is our drill. Suppose this is the drill. This one is the drill. Now the diameter of the drill will be equals to the diameter of the hole. Okay. Now so what we'll do, we have to select the diameter of the drill based on the diameter of the hole. Next, and we have to align the axis of the drill with the axis of the hole. Now after doing that, next we have to do the machining work, means we have to make the hole. Okay, so we have to do the machining. Now after machining, then again we have to inspect that whether the center point of the hole is at the exact distance from the center point of the disc or not. Means we have to check, or we have to inspect whether the distance of the center point of the hole to the center point of the disc is A or not. Okay, that means we have to go for the inspection. Okay, now after completion of the inspection, next the job will be completed. So now if you are asked, suppose you are asked to produce only one job. Only one, or only suppose 3 jobs. Then you can go for all these steps to manufacture this product. But if you are asked to produce 100 number of jobs, okay, then in that case, suppose for completion of 3 jobs, the total duration is required. For completion of the 3 jobs, the total duration is required, say 24 hours. Okay, now if you are asked to produce 100 number of same job, exact job with the same dimensions, if you are asked, then the total duration will be much more. If we produce the product by following these steps. Okay, and that will be not the cost effective. So what we have to do, we have to use some systems so that we can eliminate few of the steps among these steps. Okay, now if we can eliminate those steps, then we can reduce the total duration for completion of 100 number of products. Okay, now from that point, the introduction of jigs and fixture comes. Means jigs and fixtures are introduced based on these, to overcome these limitation of the job size productions. Okay, now when we will, that means we can overcome this problem by eliminating this marking, punching, mounting and fixing, these 3 options. Okay, now how we can eliminate these 3 options? Rather, we cannot eliminate these three things. We can merge these 3 things in a single one. And here what we are doing, that we were individually at first marking, then we were punching it, and then we are mounting and fixing it. Now if we have a device where if we put this workpiece, and automatically when we will fix this one, automatically it will get located, it will get fixed, and it will get mounted automatically. Then we can eliminate these 3 steps. Now for this total, for the total duration of the machining, you can see that the total duration for these 3 points is more than these portions. So if we can eliminate this one, these 3 points, then we can produce the products quickly. Okay, so to meet this 100 number of products or 100 quantities of products of the same dimension, we have to use a device which can eliminate these steps, and the name of those device is jigs and fixture. Name of those device is jigs and fixture. Okay, that means whenever we will design any fixture and jig, at that time your design must have quick, it should quickly locate the job, it must quickly locate the job, it should quickly support and clamp the job, support and clamp the job, and the location must be accurate. The location must be accurate each of the time. That means whenever you will put the workpiece into the fixture and it will hold, the fixture will hold the job, every time the distance of the center point of the hole, the distance from the center point of the hole to the distance of the disc to the center point of the disc will be A. That we have to ensure. Okay, then only we can produce 100 number of products in shorter period of time with higher accuracy. Okay, so that is the purpose of using a fixture. Now when we have to drill it, when we have to when we have to make a hole on this disc, we have to use the drill. So when we will use the drill, we have to guide the drill so that the drill bit can pass through the exact center point of this hole. Now to guide the drill, we have to use another device, and when we can guide the tool, at that time those type of fixtures will be called as jigs. Okay, that means what is the difference between fixture and jig? Fixture means where we can only give support to the job, locate the job and clamp the job. Okay, and what is jig? Jig means jig can do all these things, whatever the fixture can do, except these. The jig can also guide the tool so that the tool can pass through the exact location. Okay, that is the basic difference between a jig and a fixture. So a jig can locate the tool or it can guide the tool, but the fixture cannot guide the tool. So what is the purpose of jigs and fixture? I hope you have understood what are the purpose of jigs and fixture. So I am not discussing those things again. Now suppose we have a graph where this one is a graph where this is the machining cost. Here is the machining cost, and this one is the total quantity of production. Okay. Now if we use the job based system, means if we use the piece production, means single piece we are producing. So if we use piece production, in that case, if we draw a curve, if we draw draw the relationship between the machining cost and quantity, the quantity, with the increase in the quantity, the machining cost will get increase, right? So when we are not using any jigs and fixture, so it will linearly, it will increase. With the increase in the number of quantities, the machining cost will also get increase. Okay. Now if we use jigs and fixture, we can eliminate those steps that consume more time in case of piece production. So we can eliminate those times. So but for designing or for manufacturing of the jigs and fixture, we have to invest few money. That means there should be some investment. Okay, so this one will be the initial investment for the production of the jigs and fixture. Okay, now after that the total cost of production will be less if the total number of production is more. If total number of production is more, then the total cost of machining cost will be less than the piece production. Okay, now you are asked to produce, suppose 1000 number of products. Now you have seen that if I use some more advanced machines which can automatically clamp or hold or locate the job, as well as it can automatically change the tool also, in that case the total duration for the production of a single piece will be much more less than the piece production. But in that case, the total investment, means the initial machining cost will be much more high. Okay, but the total machining cost for the huge quantity of production, in that case the total machining cost will be less. So there will be the initial investment, but the total cost will be less than the total cost will be less than the the total cost will be less than the piece production as well as batch production. Okay, so you can see now if I divide it into two zones, then this one is one zone, this is one zone, and this one is another zone. Now below this zone, whatever the quantity is being produced is less number of quantity. Okay, so this one will be we can use piece production. In this case, means we can use the conventional the machines like conventional lathe, conventional milling. These machines can be used for the piece production. But if the number of productions are very large, huge number of productions are required, in that case we should go for the semi-automatic machines, and we can use the mass production. So this one is for the when we are using the or without fixture and jig. Okay, and this one is with fixture and jig or using fixture and jig, and this one is using the automatic machines. Now if the total number of production is much more high, in that case we can see that, or if we select the automatic machines, then it will be economical than the other thing. That means if we go for the huge number of production, we should use the automatic machines. Okay, but in between these two zones, Means suppose the number of production is more than 50 but it is less than 500, suppose. In that case we can use the uh, fixtures, and in that case we can, in this zone is will be called as batch production. Okay, so basically batch production means when the dimensions are same, okay, and we need to produce the same dimension products, suppose the 100 or 200 or 300 quantities. In that case that will be called as batch production. Okay, next is the, now the coming to the design of jigs and fixtures. So now you get to know that what is jigs and fixture, what are the purpose of jigs and fixture, and when we can use the jigs and fixture. Now we have to know that what are the means design features of jigs and fixture, and whenever we will design any jigs and fixture, what are the points we need to keep in our mind. So first thing that we need to know that what we have to design, means in the jigs and fixture what are the parts we need to design, that we need to know. So we have to know that what are the parts to be designed, parts to be designed. Okay, now the parts that we need to be designed is, the first one is the base and the body. So we have to design a base and the body, that we need to design. Next we need to design the locating element or the system. So we need to design the locating system. Okay, next we need to design the supporting system. We need to design the supporting system. Now we have to design the clamping system also. We have to design a clamping system also. Now after completion of the clamping system, if required, then we can, means we may have to design an indexing system. Okay, and except these things we have to design the auxiliary elements. Auxiliary element means the fasteners. Okay, so we need to design the auxiliary elements based on our design. Okay, so these are the things that we need to design. Now what are the factors? What are the factors that we have to consider? So the factors that we need to consider during the design of the jigs and fixture, the factors are, as I told you earlier, that we need to, whatever the clamps or supporting device or locating device we will produce, those must be strong, rigid and stable. Okay, so the whatever the supporting clamping device we will produce, that must be strong, rigid and stable. Okay, now another point is the total system or the locating of the job. The locating of the job must be accurate. job must be quick, easy, and consistently accurate. Okay, this is very, very important. Consistently accurate. Next, now the tool guidance means the tool will be guided in the jig. So the tool guidance must be accurate. Tool guidance must be accurate. Okay. Next, we need to use the standard parts. So there will be some standard dimensions, and based on those standard dimensions we have to produce our product. Now, in some cases, while we will locate our job, in some cases there may be required some adjustable screws or adjustable pins. We will be needed some adjustable pins. Now we need to also consider that how the chip will get removed. Okay. The last point is, not the last, this is the second last point, is machinability. It is very, very important. Machinability means whatever you will draw, that must be machinable. Okay, so machinability. And the last one is service life and cost. Okay, so these are the things that we need to consider while we will design jigs and fixture. Now, in the jigs and fixture, before coming into the design, at first we need to know that in a rigid body, suppose it is a rigid body, this is a rigid body, okay. Now in a rigid body there are total 12 degrees of freedoms are there, right? Now what are the 12 degrees of freedoms? Suppose this one is, this one is x axis, this one is y, and this one is z, say. Okay. Now the 1 degrees of freedom is, it can move in the positive x direction as well as negative x direction. It can rotate in the clockwise direction as well as in the counterclockwise direction. Okay. Similarly, it can move in the positive y direction as well as negative y direction. Here also it can rotate in the clockwise and counterclockwise direction. Okay, so similarly it is true for Z also. Okay, so we can see for a single rigid object, it has 12 degrees of freedoms. And while we will machine anything, any workpiece, at first we have to arrest all these 12 degrees of freedom. We have to arrest all the 12 degrees of freedom must be arrested before machining. Before machining, right? There are 12 degrees of freedoms are there. So how we can arrest all these 12 degrees of freedoms? So if I see the object, if I see this object from the top, if I see the object from the top, then the object will look like this. This one will be the shape. This one will be the shape. Now we can, this one will be the shape. Now to arrest the movement of the job, we can provide pins in from the rear. We can provide pins from the rear so that the object cannot move in this direction. Okay, so we can provide pins over here. Okay, we can provide pins like this. Okay, similarly we can provide pins for the locating purpose in this direction also. So we can provide pins in the locating direction like this. Okay, these are the 3 pins we have used. Now this is the front view. Now if I see this object from the front, then how it will look like? If I see it from the front, then it will look like this. Okay, it will look like this. And we can see this pin also in this left hand side. Okay, now always remember that whenever we have to provide support to any flat surface, we will always use 3 pins. We will always use 3 pins, and these 3 pins will be fixed type. Fixed type means it cannot be adjusted. It is fixed type. Okay, so these pins that can be seen in the top view will be shown in the front view, can be shown in the front view. Okay, it can be shown in the front view like this. Okay, now so these 3 pins can be seen in the front view. Okay, and these two pins can also be seen over here, but those will be in hidden mode. Okay, completed. Now we can see, if we see the object from this side, then how it will look like. Now if I see the object from this side, then it will look like that there will be the same view we will get. Okay, we have got the same view. and here will be the locating pins. This one is the locating pins that will come in the right hand side. Okay, and here also another portion. Okay, so these are the 3 pins and this is the pin. Okay, so now you can see we have arrested. Suppose this one is, if this one is X, this direction is X, or suppose this one is Z, and this one is suppose here you can see the product, when it will get the force, it will not move in this direction. Even it cannot move in this direction also. At both the direction it is locked. So in the front view it cannot be moved in the downward direction. Even it can not move in this direction also, but it can move in this direction, but it cannot move in this direction. Similarly here also that this portion, okay, now in this portion actually this, at this direction the degrees of freedom is 0 at this direction, and at this direction also DOF is 0. Okay, so in this way whatever the product we will get, we always have to locate it first, and then we have to after locating we have to provide the supports, and then we have to provide the clamping mechanism or clamping system. So next is, now there are some design principles or rules for locating, supporting and clamping. So first we will discuss the design principles or rules. Design principles or rules. Design principles or rules for locating device or locating systems. Locating systems. So first thing is, the first point when we have to design in the design principle or the design methods or the rules for locating systems, the first thing is, if we need to locate any flat surface, or any circular surface or cylindrical surface, there should be a pre-machined surface, there should be a pre-machined surface, because this pre-machined surface or any holes that these surface or holes will be used as a reference. That's why we will be needed the pre-machined surfaces. Next, here also the locating systems must be rigid, it must be quick and accurate. The pins of the locating pins must be strong, rigid and hard. Now the locating pins, it should be wide apart, and if we need to locate the cylindrical jobs, there are two methods. Suppose this is a cylindrical job, there are two cylindrical jobs. Suppose this one is a cylindrical job. Now this job can be held with the help of a fixture, where there is a fixture, okay, where this fixture, this one and this one, both can be clamped. Okay, both can be clamped. Now it will be connected. This one will also be connected, and it will rotate, and the machining will going on, These are the clamps, and these clamps will be fixed on a bed with the help of a suppose a nut. Okay, in this way we can hold it. Okay. Next is another way of holding any cylindrical shaped job is a V block. So with the help of a V block we can hold the job. With the help of a V block we can hold any cylindrical shaped job. So simply if this is a cylindrical shaped job, then we can use a V block we can use a V block to provide support to the cylinder, okay. Now if the surface is, instead of a cylindrical surface, suppose the surface is a flat surface. Instead of cylindrical surface, suppose the surface is a flat surface. So in this case, the pre-machined surface will be the internal surface of the hole, of the cylinder. Okay. In this case, the outside diameter or the outside surface must be the pre-machined surface. Next is, now if the flat surface must be located, in that case the flat surfaces must be pre-machined. Now suppose some irregular shaped job is there, and the lower surface is irregular, having the irregular shape. In that case we can use a arm that is called as pivoted arm, with the help of that pivoted arm we can locate and provide support to any large size jobs. There are also adjustable pins are there. In the earlier slide, you get to know that we need to use the 3 pins to provide support. We need to use these 3 pins to provide support to a job. Now, if the surface of the job is suppose this is the surface of the job. Now, if the surface of the job is not pre-machined, that means the surface of the job will be uneven. Now, if the surface of the job is uneven, then suppose here, here, and here, at these 3 points, we have already at this 3 point we have the pins that will provide support. But if the lower surface is not even, or the size of the job is quite large, in that case we can use some adjustable pins, and that adjustable pins can provide support to the job to those specific locations. So basically these pins are the fixed pins, means these pins are not adjustable in nature, but there are some more types of pins you can use to provide support that will be called as adjustable pins, means the pins that can be adjusted, that is called as adjustable pins. Okay, so these are the few general rules of the locating. Now if we need to locate any workpiece for machining on a lathe, in that case we can hold the job on a self-centering chuck, or we can hold the job between 2 centers, or we can feed the job into collets, or we can mount the job on a mandrel. Okay, and the mandrel will be held in a spindle. Okay, so even if you have a fixture, suppose this one is there is a plate that is called as face plate, and in this face plate we can fix a fixture. Suppose this one is a fixture, we can use fixture on this face plate with the help of bolts. With the help of bolts we can fix the fixture on the face plate. So to mount any fixture in a lathe, we can use the face plates. Okay, so basically in the locating pin, locating means any job, any type of job, suppose this one. Now what will be the distance of the job from these 2 walls? That is also the location of the job. So to get that location, the location of the pins will basically decide the location of the job. Okay, so we should have to use the pins accurately, so that the location of the job will be accurate, and the function or the further processes of the workpiece can be done smoothly. Now there are different shapes of pins are available. So if you check the different types of pins, then you can see there is one type of pin where there is only point contact will take place. Okay, so there will be some type of pins. Suppose there is a cylindrical job is there. This is a cylindrical job. Suppose there is a cylindrical job. There is a cylindrical shaped job. Suppose there is a cylindrical shaped job. Now suppose you need to hold this cylindrical shaped job, and in that case you are using a conical shaped pin. So the conical shaped pin will look like this. This is a conical shaped pin. This one is a conical shaped pin. The conical shaped pin. Okay, and in this conical shaped pin you can see, in the conical shaped pin you can see that there is a point contact is taking place. A point contact is taking place, right? So the point contact is at this position. At this position, only at this point there is a contact between the pin and the job. Okay, so as there is only in a point contact, it can support to the job. So basically light jobs are located with the help of these type of pins. Okay, light jobs are generally located with the help of these type of pins. Clear? Now there are some other types of pins. There are some other types of pins where, suppose this one is a job, this is the job. Suppose this one is a job and we have to provide location to the job, and this one is a pin. This is the pin. Okay, this is the pin. So you can see that in this case, the pin and the job is having the surface contact. Here you can see this is the surface contact. At these two places there is a surface contact. That means it can carry heavier loads or heavy side jobs. So for locating any heavy jobs, these cylindrical shape or round pins are generally used. Okay. Next is now we can hold the cylindrical shaped jobs or hollow shaped jobs with the other systems also. Suppose you have a object. The object is looking like this, or the workpiece is looking like this shape. Suppose there is an object which is looking like this. Suppose now to hold this object we can use a pin, and the name of that pin is called as a diamond pin. Okay, so we can use that pin, or we can use a circular shaped pin. We can use a circular shaped pin to hold this point of the job. Okay, now if we are using any circular shaped pin, then it can move in these two directions. Okay, so when it will move in these two directions, we have to provide some other pins so that it will not rotate, it will not move in these directions. So suppose here we have provided a pin. Now after providing any pin over here, now it cannot move in this direction. Now it cannot move in this direction. Okay, so from this direction we can provide the clamping force so that it will not get moved in this direction. Okay, or instead of the circular pins we can use another shaped pins, that is called as diamond pin. So instead of circular shaped pin we can use a diamond pin also to hold the job. Okay, so next is So these are the locating pins. Now in case of supporting pins, in the supporting pins, as I discussed earlier, that there should be minimum three supporting pins must be there, and the other extra supporting pins means the whatever the extra supporting pins we will use, those pins must be the adjustable pins. Due to the change in the surface, means change in the surface of the base, the adjustable locating device or the supporting device will be useful. The next point is, suppose this one is your product, this one is your product, and in this product you have provided support at this end and you have provided support at this end. At both this end you have provided support, and the load is acting. Now if this gap is too large, then this plate can be deflected due to the application of the force. It can get deflected. Okay, so what we need to do so that it will not get deflected, always we will provide some pins or supporting system below the application of the force. So here it is application of the force. Here we can provide a pin so that it can resist the application of the force. Okay. Next is, so this one is the supporting system. Supporting part is completed. So the locating part is completed. Next the supporting part is completed. Now after completion of the supporting part, next we will go for the clamping portion. So in the clamping portion, there are different types of clamping systems or mechanisms are available, and it is not possible to discuss all those different types of clamping systems. So I will discuss few of the clamping systems. Rest of the systems you will check from the books that I will share with you in the Google Classroom. Okay, so now what are the different types of clamping devices are used. Now basically the clamping devices will also must be strong, and it must be rigid and stable, and here also the clamping system must be easy, quick, and it must be adequate. Okay, now as I told you that the clamping force should act against the part and should act against the part, against any rigid part, so that it will not damage the job. Okay. Now the material of the clamping device and the locating and supporting device must be such that the material will not, the material must be wear resistant and it will not get failed easily. Okay. Achha. Now the clamping should be foolproof, so that during the working or during the operation the product will not come out from the device. The clamping system must be reliable and it must be safe, and another thing is the low cost, because here if the cost will get increased, then the total machining cost will also get increased. So next, there are few clamping devices are available. So among those clamping devices, suppose there is a job. Suppose there is a job like this one is a job, and we need to provide the clamping system to hold the job. So what we can do, this is the job, we can apply any force so that the job will get fixed. So to provide the force here means we should have some type of mechanism through which we can apply the force. We can apply the force. Okay. Now, now, so suppose with the help of this type of bar, we can provide force on this job. Now, this bar or this lever, this is connected with a part. This is the part with a part, and then there is a screw. Suppose over here there is a screw. There is a screw over here. Suppose this one is a screw. Okay, this one is a screw. Here is a screw. Now the screw, there is a screw, this one is a screw. Okay, now if we rotate the screw in the, suppose, the clockwise direction, it will move in the downward direction. So when it will move in the downward direction, it will apply force on the job, so it can hold the job. Now after completion of the after completion of the work, after completion of the machining operation, there will be some springs over there at these points, and it will apply force on this bolt, so that on this screw, so that it can be lifted to its initial position. Okay, now there are one washer is existing over here at this point. There is a washer, and the name of this washer is a spherical washer. The name of the washer is a spherical washer. Now what is the purpose of this spherical washer? This spherical washer, what it do, it generally maintain the it generally helps to make the surface of the bolt and nut, it always try to keep these two surface as parallel surface. So how it works? Whenever we will apply any force, what will happen? There will be the total force will act on this bolt. Okay, if the alignment will get changed, when we will apply any force, the total force means the total force will act on this bolt. As a result, the bolt may get failed. Now this spherical washer, what it do, due to its shape, the spherical washers are looking like this type of shape. This is the shape of a spherical washer. Okay, so what it will do, when you will the force will get applied, when the force will get applied, maybe the bolt will get tilted, but the surface, this surface will be parallel to this one. Okay, so as a result, when the force will be released, the spring will apply a force and the screw will come into its initial position and the job can be released. Okay, so this is the ordinary method of clamping. Now there is a method that is called as quick clamping. Now in the quick clamping, there are various methods of clamping, so just check all those methods from the books. I'm just discussing another method that is called as quick clamping method, and under the quick clamping method there is a nut, and the name of that nut is a quick acting nut. So how that nut will look like? So the quick acting nut is looking like that. There is a thread like this, there is a thread like this. Okay, there is a thread like this. Okay, there is a thread like this. This is the shape of the nut. The name of the nut is quick acting nut. Okay, this is the shape of the nut, and the name of this nut is quick acting nut. Now how it works, how this quick acting nut will work. The quick acting nut, when it will engage with the job, what will do, the motion is, the quick acting nut, this will be forced in this direction, so it will move in this direction, it will move in this direction, then we will rotate it, then after pressing it in this front direction, then we will apply the force. After pressing it in this direction, we will apply a force so that this thread will be aligned. So we will apply a force so that these threads will get aligned, and after getting aligned, then we will rotate it in the clockwise direction so that the thread will get engaged with the job. The thread will get engaged with the job. So at first we will press the nut, then we will apply the force so that these threads will get engaged with the thread of the shaft or the job, and then we will rotate it in the counterclockwise direction. Okay, so in this, with the help of this quick acting nut, we can quickly hold the job so that we can perform the job quickly, and within a short period of time we can perform more number of products. Now there is another way of quickly clamping the job is by using a cam. Okay, so I will show you that by using a cam how we can hold any job. Okay, so now I'm discussing one problem so that you can get understand. So the problem is, suppose you are asked to make the we have to make a hole on a cylindrical object. So this one is our cylindrical job where we have to make a hole at the center point. Okay, so this is the side view and this one is the front view. Now we have to make a fixture or jig which can provide support, and which can locate the job as well as provide the support as well as to clamp the job. So as in this job, now we have to decide whether we have to produce a jig or a fixture. So as in this problem, we have to make a hole, and always remember that the drill is a slender tool. A drill bit is a slender tool. It is a slender tool. Okay, so as it is a slender tool, so there is a chances of uh, getting the exact location of drilling. As a result, if you are using any drill bit, if you are directly wanted to make a drill with the help of a drill bit, at this point it may happen that when you are trying to make a drill at this point, it may move in this direction or in this direction during the movement. Okay, so we have to ensure that the drill is working, or the drill bit will work at the same location each of the times. Okay, now to ensure that, we need to guide the tool, we need to guide the drill. So to guide the drill, we will use a tool, and the name of that tool is bush. Now in this problem, as we have to make a device which will give support to the job as well as guide the tool, so we have to make a jig, not a fixture, for this device. We have to make a jig, not a fixture, for this device. So you have to decide whether we will design a jig or we will design a fixture. Now if we have to design a jig, then the first point that we have to do is, always remember, we need to do is locating. So at first we need to locate. So first point is a locating. So we need to locate it. So we have to locate the object with the help of locating pins. So here in this problem, at first we need to before locating, at first we have to align the axis of the job with the axis of the tool. That we need to do. So at first we have to check whether the axis of the tool is aligned with the axis of the job, because here the drilling will occur. So the axis is aligned at the same line or not. Okay, so alignment is completed, means this is the actual position of the job. Now we have to locate the job with the help of a locating pin. So now we have to locate the job with the help of a locating pin. So with the help of locating, we will locate the job. Next we have to provide the support, and as we know that for cylindrical shaped job we can use V block to provide support. This we know. So we will provide support with the help of V block. Now in the V block, you can see there are the recess. There is a recess, there is a gap. This gap is called as recess. Now why this recess is provided? So that to ensure the proper contact of the job with the V blocks at these zones. At these zones, this recess is given. Okay, so we need to provide a recess for the in case of large sized jobs. Now after completion of the locating, next we have to provide the support. So we have already provided the support with the help of V block. Now after providing support, next we have to clamp the job. We need to clamp the job. So here we have clamped the job with the help of a cam shaped or cam type clamping system. Okay, so in this case we have used a cam type clamping system. So now I will show you that how this cam type clamping system will work. So this one is a cam clamping using cam clamping using cam. Okay, so let's see how it works. So it is also under the category of quick clamping. Okay, so now let's see how it will work. So there is a in the cam clamping, actually there is a clamp, and when there is a lever. Now when we will push the lever in the downward direction, when we will move it, then a force will be applied on the screw, and it will apply a pressure. Means the screw will apply a pressure. Okay, so it will apply a pressure on this pivoted arm, and this pivoted arm will apply force on the object. Okay, this pivoted arm, or this is called as pivoted clamp. This one is called as pivoted clamp. This pivoted clamp will apply force. On the job. Okay, now after completion of the machining operation, then when we will release this lever, then again this spring will apply force on this screw, and it will get lifted. It will automatically get lifted, and we can remove the job. Okay, so this is the clamping system in this case. Now after completion of the clamping system, next the system that will be needed. So after the clamping system, the system that will be needed is machining. Okay, before machining, we will use a pusher type device that can apply a force, an axial force in this direction, so that it will get ensured. It means we can ensure it more that the product will not move during the operation. Okay, so one pusher we can use along this axis. Now here we can use a swing type pusher. We can use a swinging pusher. This is a swinging pusher. So we can use a swinging pusher to push the job. This one and this one both are a swinging pusher. Okay, so this swinging pusher will apply force on this job, so that the job will not come out in this direction. Okay, now there is a spring that is connected with the V block. Okay, now when what we'll do, we will, after completion of the job, when we have to remove the job, we will move this swing pusher in this position from, suppose, point A to point B. It will get moved, and when it will get moved, we can remove the object, and after removing this object, then due to the spring, it will automatically again come to point A. Okay, this is called as swinging pusher. Acha. Now after clamping, next we have to perform the drilling operation. Now, as I told earlier that the drilling operation will be performed, and during the drilling operation we need to guide the tool, and to guide the tool we have to use a device, and that the name of that device is bush. Here you can see that this one is a bush. This green colored object is a bush, and it will guide the tool to make a drill at this center point, and repeatedly each of the time this bush will provide, or this bush will guide the tool to make a drill at this center point. Okay, so this is called as bush. Now this bush can be of two types. Here you can see this bush is of two types, and in this case basically the bush is of two types, and the types are one is the headless, another one is a headed bush. Okay, so here this one is called as a headed bush because this one is called as the head of the bush. This top portion is called as the head of the bush. That's why it is called as headed bush. Now when we take out the drill bit after the machining operation, there is a tendency of coming out of the bush with this drill bit. Now to eliminate that chances, what we'll do, we can use a pin. These are the pins. We can use pins that will hold the bush at its position. Even when we will take out the drill from the bush will not move or will not come out with the drill bit. Okay, now there are advantages of this bush. The advantages are basically the bush will help the drill to it will guide the tool so that the tool can hold at the exact location for the job. Okay, now suppose after some time, after machining of 50 pieces, the internal surface of the bush, is suppose wear out. Okay, although the material of the bush must be wear resistant, but suppose after a long period of time the internal surface is already totally wear out. Okay, so at that time what we can do, we can remove this bush and we can provide a new bush at this position, and we can continue our processes or operations. Okay, now there is another advantage of using a bush, that is suppose you need to make a hole, and that hole, the diameter of that hole is smaller than the diameter of the bush, than the diameter of the existing bush. So in that case what we can do, we can use another bush which is having the same dimension of the hole, and if we use that bush, then we can easily make a hole on the surface with the help of another drill bit which is having the same dimension of the hole. Okay, so that is the advantage of using a bush. And these locator pins are adjustable in nature, because if any means if the axes are not aligned properly, then with the help of this locating pin we can we can move the object a little bit so that the alignment of the axis will get matched. Okay, now next there is another device, and that device is called as ejector. Basically, the purpose of using ejector is after the completion of the machining operation, then when we need to remove the object, what we can do, we can remove this swinging pusher, and after removing this swinging pusher, next with the help of this ejector we can apply force on the ejector, and it will apply force on the object, and the object will get removed. And after getting removed of the object, then this ejector will come out to its actual or original position due to the springs of these ejectors. Okay, so this is a simple design of a jigs and fixture, where we need to make a hole at the center point. Okay, so in this way you will be needed to make the design of the jigs and fixture. Now in your case, suppose whatever the problem will be given to you, that all the problems will be based on the drill jigs. Now I will share the books with you. All of you go through the books, check the books. You will get many types of different types of drill jigs, and the clamping device, locating pins are available, that you will get to know. And whatever the workpiece I will provide, or whatever the job I will provide, based on that job you need to design a drill jig, and you need to design the drill jig based on the dimension of the object. You need to design the drill jig, as well as you have to provide the dimension also. Okay, next is in the drill jigs you have to find out the dimensions for each of the systems. Okay, so you need to design for the holding systems or the locating systems. You need to design the holding system, as well as you need to design the clamping system. So all the dimensions, based on the dimension of the object, you have to find out what will be the dimension of the various systems that will be responsible for the operation. Okay, so this is the these are called as drill jigs, where we can guide the tool also. So first you check this video, and if you find any doubt, then you can ask me the questions, and I will provide you the problem for you, the problem that you need to solve or you need to design. So I will provide you that problem, and all of you will have the different problems. Each of you will have the different problems. So all of you need to understand that how you can design it. Go through the books. If you find any difficulty, you can ask me. Okay, so thank you.